Good morning, students. I am Anilkumar K, science teacher working in Sri Gurupadeshwara English Medium High School, Sanehalli. Okay, students. In today's class, we will going to discuss about the chapter called as electricity. You already familiar with the word electricity. We know that. What is that? Without electricity, our lives are zero. How? Just take an example. If you are using a mobile phone, it requires electricity. If you are going to watch a TV, it requires electricity. If your mom going to make food, okay, she has to grind something, she requires electricity. Okay, for all purposes, okay, for all purposes we require electricity. How the electricity works and how it is produced, that we will discuss in the next chapter. But in this chapter we will discuss about what is electricity, what are the concepts related with the electricity, okay, and in detail we will study in this chapter. Okay, we will move to the concept called it as electricity.
Okay, students, in this chapter we will learn the concepts of electric current and circuit, electric potential and potential difference, circuit diagrams, Ohm's law, resistance and resistivity, resistance in series and parallel combination, heating effect of electric current and its practical applications, and also we will do some problems on this chapter. Okay, the first concept, electric current and circuit, we will discuss that one. We will discuss first what is a circuit. Here students, you are looking at torch. Here is a switch. When the switch is on, the torch starts glowing. When the switch is off, the torch does not glow. Okay, then what is the function of switch? We will see by the circuit. Here is the simple circuit of a torch, a battery, switch and a bulb. Battery is connected to bulb via switch. Switch open, that means when the switch is off. Switch open, that is switch is off. There is no connection between battery and the bulb. There is no connection between battery and the bulb. Similarly, when switch is closed, that means switch is on. Battery and bulb are connected by a switch. Therefore, the current is flow through this circuit and bulb starts glow. Then what is the function of a switch? That we will see. Switch makes the conduction link between the cell and the bulb. What is the function of switch then? Switch makes the conduction link between the cell and the bulb. Look here. Here is a battery and here is a bulb. It makes a link between bulb to the battery. Therefore, switch makes the conduction link between the cell and the bulb. Next is circuit. What is circuit then? A continuous and closed path of an electric current is called an electric circuit. A continuous and closed path of an electric current is called an electric circuit. Look here. Here is the battery and here is the switch and here is the bulb. How they are connected? Look at continuous. Okay. Is any break in the path? No break in the path. The path is continuous. And closed, they say closed. Here it is started from the battery, positive terminal of the battery is started and it going and it's coming to the negative terminal of the battery. Where it started, that is it come. Where the path is started, the path is ended there only. Then we say that this type of connection is called closed connection. Therefore, here the path is continuous, there is no break and it is closed. This type of path for electric current is called circuit. That is a continuous and closed path of an electric current is called an electric circuit. Look at the circuit. The circuit is, the path of the circuit is continuous, there is no break and the path is closed. Then this type of connection is called as a circuit. The next, electric current. Before we are going to define electric current, we will know the basic concept of electric charge. You were all already discussed in the 8th standard the model of an atom. Okay. Inside the atom, what are there? Electrons are there, neutrons are there and protons are there. Inside the nucleus atom, we have a nucleus. The center part of the atom is called as a nucleus. Inside the nucleus, there are protons and neutrons are binded. They are binded, and around the nucleus, electrons are revolving. Look at here, this is the revolving. Okay, electrons are revolving around the nucleus. In the 8th standard, you discussed about protons are positively charged, electrons are negatively charged, neutrons are neutral. Neutrons does not possess any charge, they are neutral. Protons positively charged, electrons negatively charged. Then what is a charge? Charge is a property of having attraction or repulsion. Charge is the property of having attraction or repulsion. For example, if you take two magnetic pieces, if you take them closer, what will happen? Those are attract each other. If you consider north pole of the magnet and north pole of the magnet come together, what will happen? They will repulse, they do not attract, they will go away. Same manner in the charges happens. When the positively charged are repulse each other, positive and negative charges are attract each other. Okay, that is the concept of charge. Charge is a property having repulsion or attraction. Okay, then what is the definition of electric current? The definition is, electric current is expressed by the amount of charge flowing through a particular area in unit time. Or we can define, the rate of flow of electric charges is called electric current. The rate of flow is nothing but amount of charge flowing through a particular area in unit time. Okay, the rate of flow refers as charge per unit time. Rate refers here charge per unit time. Electric current is expressed by the amount of charge flowing through a particular area in unit time, or we can define, the rate of flow of electric charges is called electric current. Look here, we taken a cylindrical conductor. Conductor means what? Conductor is a one which passes electricity through it. Then we call it as it is a conductor. electricity conductor. Okay. Here we taken a cylindrical conductor which is sliced. When we slice a cylinder, we will get a circle. Okay. This is what we consider, it is a small part of a cylinder. Circle is a part of a cylinder. We consider that area of that circle. Current equal to flow of charge. This circle area we consider, and number of charges are flowing through that area. How much charge or the charge flowing through this area, in a time t gives you the electric current. Okay. Unit time, that is the number of charges which are flowing, through this area in unit time gives the electric current. Okay. Note that electrons constitute the flow of charges. Who creates the charges then? Flow of charges, electron constitute the flow of charges. Remember, electrons are responsible for the flow of charges. Next, then what is the mathematical expression of electric current? Then we will give the mathematical expression for the electric current. If net charge Q flows across any cross section of a conductor in time t, then the current I through the cross section is given by, if Q is the amount of charge flowing through the cross sectional area of a conductor in time t, then current I is given by the equation I is equal to Q divided by T. I is equal to Q divided by T. Here I is electric current, Q is electric charge, T is time taken. Therefore, the expression for current I is equal to Q divided by T. Okay. Then what are the SI units of charge, time and current? We will see. SI unit of electric charge, system of international unit, that is SI unit of electric charge Q is coulomb, that is given an capital C. Coulomb is represented in capital C. This is the SI unit for electric charge. SI unit of time T is second, that is represented in small s. And SI unit of electric current I is ampere. The SI unit of electric current is ampere and it is represented in capital A. While writing in a word, you have to use the small letters ampere, and if you want to represent that in a symbol, you have to write capital A. Here also coulomb in small letters, C is capital. Charge of Q is capital C. SI unit of electric charge Q is coulomb, that is represented in capital C. SI unit of time T is second, that is represented in small s, and SI unit of electric current I is ampere, that is represented in capital A. SI unit of electric current is named after the French scientist Henri Ampere. Okay. This SI unit of current is named after the French scientist Henri Ampere. Then we will see Henri Ampere. Who is Henri Ampere? Henri Ampere, he was lived in the year 1772 to 1836. He is a French scientist and mathematician. He done the work on electrodynamics. His major work on electrodynamics. He is the Henri Ampere. His work on electrodynamics. To honor him, To honor him, the SI unit of current is named as ampere. The SI unit of current is named as ampere. He is Andre Marie Ampere. Definition of 1 ampere. Definition of 1 ampere. Then what is 1 ampere? We know that the expression for current I is equal to Q divided by T. I is equal to Q divided by T. So, in the place of I, we want to require 1 ampere. We put 1 ampere is equal to charge is 1 coulomb divided by the time taken is 1 second. 1 ampere is equal to 1 coulomb per second. 1 coulomb per second. The definition is 1 ampere is constituted by the flow of 1 coulomb of charge per second. 1 ampere is constituted by the flow of 1 coulomb of charge per second. 1 coulomb of charge per second. That is, if you consider the area, particular area, only 1 coulomb of charge, 1 coulomb of charge passed through that area in 1 second. Then we say that the current is 1 ampere. If 2 coulomb per 1 second, 2 ampere. If 3 coulomb per second, 3 ampere. If 4 coulomb per second, then it is 4 ampere. Then in particular area, how much charge is flowing in 1 second, that gives the ampere. 1 ampere, 2 ampere, 3 ampere, like that. 1 ampere is the 1 coulomb of charge per second. If 1 coulomb of charge is flowing in 1 second, then it is considered as 1 ampere. And also the smallest quantities of current can be expressed. What are those? Milliampere and microampere. Milliampere, that is 1 milliampere is equal to 10 to the power of minus 3 ampere. And microampere, 1 microampere is equal to 10 to the power of minus 6 ampere. Next, we will go to the concept of direction of electric current. Then in the circuit, how do we consider the direction of electric current in the circuit? Okay. Earlier days, electric current was considered to be the flow of positive charges, and the direction of flow of positive charge was taken to be the direction of electric current. The electricity was found by Benjamin Franklin. In earlier days, what happened? They thought that the electric current is the flow of positive charges. Is the flow of positive charges. In those days, they considered the flow of positive charge is the direction of electric current. Okay. So, the direction of electric current is taken as positive terminal of battery to negative terminal of the battery in a circuit. The direction of electric current in a circuit, we always consider positive terminal of the battery to the negative terminal of the battery. Here you look, this is the big line is positive terminal and this is a smaller line is negative terminal. The current is emitting from the positive terminal of the battery and it flows and flows, then it comes to the negative terminal of the battery. Therefore, the direction is positive terminal to the negative terminal of the battery. The direction is positive terminal to the negative terminal of the battery. But note that electrons are flow opposite to the direction of electric current. Earlier we discussed. What is that? Electrons constitute the flow of charges and flow of charges constitute the electricity, that means current. Okay. Electrons constitute the flow of charges constitute current. Okay. Indirectly, electrons are responsible for electric current, but the direction of electrons are not considered as the direction of electric current. The positive charges are considered as the direction of electric current. That means positive of the battery to the negative of the battery. And note that the electrons flow opposite to the direction of electric current. If the direction of electric current is positive to negative, then the flow of electrons are negative to positive. The flow of electrons are negative to positive of the battery. Okay, remember. we used here a ammeter and a plug key. Then what are the function of these two? We will see. Ammeter measures electric current in the circuit. What is the function of ammeter then? Ammeter is a device which is connected in the circuit, which measures how much current is flowing in the circuit. How much electric current is flowing in the circuit, that is measured by the ammeter. Ammeter measures electric current in the circuit. Note here, ammeter is always connected in series in the circuit. The ammeter is always connected in series in the circuit. Look here, the end of the bulb is connected to positive terminal of the ammeter and negative terminal of the ammeter is connected to the plug key. This type of connection, end to end connection, this type of connection is called as series connection. The ammeter is a device which measures electric current which present in the circuit, okay, and it is always connected in series in the circuit. And plug key, it acts as same as switch. It makes the conduction link between battery and other components of the circuit. Whatever the switch works, okay, the same function is done by the plug key. It makes the connection, that is conduction link between battery and the other component of the circuit. The next is number of electrons making 1 coulomb of charge. Okay, we discussed electrons constitute flow of charges. Then how many electrons make 1 coulomb of charge? Then how many electrons make 1 coulomb of charge? Solution. We have charge of an electron E. Already you know in 8th standard, charge of an electron E is given by, that is how much? 1.6 into 10 to the power of minus 19 coulomb. The charge of an electron is 1.6 into 10 to the power of minus 19 coulomb. So, Q is the charge, N is the number of electrons, E refers for electrons. To make 1 coulomb charge, number of electrons. So, Q is equal to Ne. N number of electrons makes 1 coulomb of charge. So, we consider, we do not know how much, we consider N number of electrons makes 1 coulomb of charge, that is N number. From this equation, what will happen? N equal to Q divided by E. N is equal to Q divided by E. N is equal to Q divided by E. Therefore, N is equal to, in the place of Q, we want how much? 1 coulomb. 1 coulomb. N equal to 1 coulomb divided by E. We know that the charge of an electron 1.6 into 10 to the power of minus 19 coulomb, that is 1.6 into 10 to the power of minus 19 coulomb. If we divide this, C get cancels, coulomb get cancels, only remaining is 1 divided by 1.6 into 10 to the power of minus 19. If we divide this, we will get the value N is equal to 6 into 10 to the power of 18. 6 into 10 to the power of 18. No unit. Why no unit? C get cancels. Therefore, no unit. Only it represents a number. Only it represents the number. Therefore, n is equal to 6 into 10 to the power of 18. So, 6 into 10 to the power of 18 electrons, 6 into 10 to the power of 18 electrons are required to make 1 coulomb of charge. So, 6 into 10 to the power of 18 electrons are required to make 1 coulomb of charge. Remember this. Okay. We will continue further concepts in the next class. For that, we will give the home assignment for your understanding. What does an electric circuit mean? You have to define an electric circuit. Define the unit of current. Define the unit of current, that means 1 ampere you have to define. How many electrons constitute 1 coulomb of charge? Okay, here we give the one problem, fourth question, one problem. You have to do the problem using I equal to Q divided by T. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. Here I is given 0.5 ampere and time t is given 10 minutes. You have to find the Q. You have to find the Q.
Okay students, I hope you understand the various concepts of electricity, and further concepts we will continue in the next class. Before that, you have to make answers for the home assignment is given to you. Okay, make the answers for every question, and at the top of the paper put your name and send the photocopy of that to me. Guys, note that at every pages you have to put your name. Okay, and send those photocopies to me. And further concepts we will discuss in the next class. Students, stay at home, stay safe. Okay, further concepts we will continue in the next class.